Okay, thanks for joining me for part 2 of your geometry quiz review for sections 1, 2 through 1, 4. So we'll pick up right with example 3. Example 3 has to do with the distance formula. So we need to find the distance between G, which is going to be a point at -2, 4, and H, which is a point at 5, 5. That's 5, 5. Okay, so we need to find that distance. So let's recall the distance formula. This is something you need to remember. D equals D for distance, x2 minus x1 squared plus y2 minus y1 squared, all inside a square root. Okay, and typically what we do is we label the points x1, y1, x2, y2, and we just fill it in. Now we can call D, the distance, actually the length, GH, the length between the two segments, GH. So that could be our distance D. So we fill in our numbers. x2 is 5, x1 is -2, so I'll do minus a -2. Notice I give -2 its own little parenthesis. Plus, go back to y2, which is 5 minus 4 squared, and that's all inside its own parenthesis. So we'll simplify this. I'll go out to the right here. So this becomes plus plus right here, and we get 5 plus 2, which is 7, and 7 squared is 49. Plus, we get 5 minus 4 is 1, and 1 squared is 1, and that's still inside a square root. So we have GH equals the square root of 49 plus 1 is 50, and here's where you have to do that simplified radical form. Are there any perfect squares that can divide into 50? And the answer is yes, 25. 25 is a perfect square. So it's 25 times 2, that is 50. So what happens is we take the square root of the perfect square. So the square root of 25 is 5. The 5 will come out, and the 2 is left inside. This 25 goes away once the 5 comes out. And that is the length, or the distance between G and H, and it's in simplest radical form. Okay. All right, next one, another distance problem. So don't lose that formula. We're going to take a look at that. There was a problem in your textbook, the Louisiana problem. We're going to look at that again, except we're going to pick a couple different locations to go from. So in your book, there was a map on page 23. Now you don't need the map. You can just look on what I'm doing here. And we went from Appalachia, okay, which was given coordinates 46, 5. And then there was a place called Bunkie, which was given coordinates 40, 32. And then there was a place over here called Villa Platte. And Villa Platte had coordinates 36, 12. So the road map looked like this. It went from Appalachia to Villa Platte, and from Villa Platte up to Bunkie. And I want you to tell me, how far is it from Appalachia to Bunkie? And we are going to get to use our calculators in this problem, so you'll see how that goes in a second. All right, so make sure you have a calculator handy. So we need to find two distances. We're going to call this distance OV, and we're going to call this distance VB. Two distances. So let's find the first one, OV. Okay, so it's using the distance formula. We're going to let Appalachia be our x1, y1. So Villa Platte will be x2, y2. So that means that we'll take Villa Platte's first, 36 minus 46, and square it. And then go back to Villa Platte, 12 minus 5, and square it. And that's all inside a square root. So 36 minus 46 is -10, and -10 squared is 100. 12 minus 5 is 7, 7 squared is 49. So therefore we add those together and we get the square root of 149, and here's where your calculator comes into play. We do this in our calculator. The square root of 149. And the square root of 149, let's go to one decimal. I got 12.2. And the units here are miles. And again, you'll be given units on the test or whatever. So then let's find the distance between Villa Platte and Bunkie. We already have Villa Platte as x2, y2, so let's label Bunkie as x1, y1. So we start with Villa Platte's coordinates first. 36 minus 40, right, that's squared, plus, go back to Villa Platte, 12 minus 32, and we square it. And that's all inside the square roots. So this is going to be 36 minus 40 is negative 4. Negative 4 squared is 16. 12 minus 32 is negative 20. Negative 20 squared is 400. So we add them together. 416 is inside the square root, and here's our calculator. The square root of 416 equals 20.4. Round up. So to find the total distance, I'll say t for total, we just add the two together. 20.4 and 12.2 is 32.6 miles. And there's the distance from Opelousas to Bunkie. Okay? Alright, and then one more problem I wanted to go over has to do with the angle addition postulate. So this is the fifth and final problem, and we're talking about the angle addition postulate. Very similar to the segment addition postulate, except works with angles. So I'm going to give you a problem. It's going to say that ray OQ is in the interior of angle POR. Okay, so the first thing is I would hope you can set this up. So let's put angle POR. Let's make an obtuse angle, okay, and make it relatively large because you might want to write on it. Okay, remember, angles, two rays connected together at the same point. This is angle POR. And then they say ray OQ is in the interior. So that means that we have a ray coming up like that from O through Q. And now they're going to give us some information over here. They're going to tell us that the measure of angle POQ equals 3x plus 7. And this is degrees, so they usually put parentheses degrees. The measure of angle QOR is 5x minus 2. And then the measure of the big angle, angle POR, equals 61 degrees. And they want us to find x and then the measure of the other angles, these two angles up here. So using the angle addition postulate, we will say that, and I'm going to scroll down here, we'll have the picture involved. We're going to say that the measure of angle POQ plus the measure of angle QOR is going to be equal to the measure of angle POR. And hopefully you wrote down, I can kind of see them up here. We're going to just plug in the expressions. The measure of angle POQ is 3x plus 7. The measure of angle QOR is 5x minus 2. And that should equal 61. So we combine like terms. 3x and the plus 5x, and we get 8x. Plus 7 minus 2 is plus 5. That's going to equal 61. 2 steps, subtract 5 from both sides. 8x equals 56, and divide by 8. And you're going to get x is equal to 7. So there's the value of x. So now we plug it in over here to find our individual angles. So we add the measure of angle POQ is equal to 3 times 7, which is our value of x, plus 7. So we get the measure of angle POQ equals 21 plus 7, which is 28 degrees. Okay, make sure we label in degrees. And then the measure of angle QOR equals 5 times x, which is 7, minus 2. So the measure of angle QOR is equal to 35 minus 2, which is 33 degrees. 33 degrees. And if you take a look at those two angles, if you add them together, you get 61, which was the original angle given. So there are 5 problems that you should know how to do in order to do well in your quiz on Friday. All right, thanks for watching. We'll see you again.